11.69. Wait, round to the nearest 100?
I was going to say tenth.
Oh, 11.7.
I got to admit, I have not done this question ahead of time. I think that answer seems a little high. I think it seems a little high.
So you want me to square root 11.7?
In my walking around and watching what you did. So the first key phrase here that we want to maybe identify is, hitting the ground. Hitting the ground is pretty much synonymous with height being 0. And if you think about it, like I said earlier, I hope that makes sense when it says how long will it take to hit the ground. That is a question of time. So it would look something like this on our setup. 0 equals negative 16t squared plus 187. And as I walked around, I saw a variety of ways that you solve this. It's kind of convenient that the coefficient on the t-squared is a perfect square. If it wasn't, it would maybe be a little less convenient. I want to give you guys kind of a general rule to do on all of these, and that would be this. We want to get the t-squared, or whatever quantity is being squared, we want to isolate that first before we square root. And so I would say something like this. If I add 16t squared to both sides, I get 16t squared equals 187. At this point, I would divide by 16. I really think, from a consistent basis, this is your best course of action. So I divide both sides by 16, and
11.7.
I get t squared is equal to, you said that's 11.7, Sam?
Yeah.
Okay, so approximately 11.7,
No, 13.7.
13.7.
Oh, this is how we're doing. No, it's 11.7.
Okay. Then, after you've done that, then you square root both sides. You get t equals plus or minus approximately 3.4 if you do round to the nearest tenths place. Just the plus, right? Because the object's not going to hit the ground 3.4 seconds before you dropped it. So we would just say 3.4 seconds for the time to hit the ground. Okay, timeout, yes.
Timeout.
And that was great for chapter 6 because we were just learning and practicing how to factor. But in chapter 9, we're really expanding your world into a lot more quadratics, right? Ones that have answers that are not quite so nice. And so we're looking at techniques on how to solve those. We just practiced a little bit at the board. We'll practice some more here in a little bit. But we're going to look at another technique. This is a technique that is very handy because this technique, I'll highlight it for you, completing the square. Factoring only works in specific situations. Completing the square always works. It does not matter how complicated or simple a quadratic is. It could be super easy. It might have answers that are decimals. It might have answers that are whole numbers, integers, whatever. But this will always work. Okay, factoring does not always work. Sam, you found that out, right? Factoring does not always work because that one that you tried factoring didn't work. This will always work 100% of the time. It'll always give you the correct answer as long as we do the steps right. So in order to do this, I actually want to go back and review some special factoring patterns. If you guys would, take just a second and please do the two factorings that you see right there. X squared plus 8x plus 16, x squared minus 10x plus 25. Please just take a moment and factor those two polynomials. All right, does anybody have the factoring on the first one? What is it, Christiana? No, I'm not looking for an answer. Notice that in that...
Oh, sorry. X plus 4, X plus 4.
There you go. So she said x plus 4, x plus 4. Would it be okay if I wrote this as x plus 4 squared?
Yes.
Okay. Do you have the other one, Ellie?
Yep.
What do you got?
X minus 5 squared.
That's exactly right. X minus 5 times x minus 5, or probably better written x minus 5 squared, like she said. Did you guys, were you all okay with that? Or factoring like that? You have any questions? Okay, fair enough. So I want you guys to notice a pattern. A pattern should show up here when you compare the number in the factoring with the b term. So would you do that really quick? What do you think? What's the pattern between the number in the factoring and then the original b term? What do you see, Amelia?
They're both the same number.
What are the same numbers?
5. When you factor out like what two things multiply to be.
Okay, right. So it's a perfect square. I agree. I totally agree with you. It's a perfect square. But what? So the first one, what's the b?
8.
8. How does that compare with the number within the factoring?
It's double it, right?
Yeah. So the 4 is half the 8, right?
Yeah.
Do you see the same pattern in the other factoring?
Oh yeah.
The negative 5 is half of the b. That make sense?
Yeah.
So we call these factorings, we call them perfect square factorings because it's x minus 4 times x minus 4, or plus 4 I should say, and it's x minus 5 times x minus 5. Not only do they factor, but they're perfect square factors. Okay, and so this pattern of the number in the factoring is half of the b is quite important. We're going to look at how to create perfect squares, right? And so let's take a look here at the next little section about how to complete a square, to create a perfect square. So check this out. So we're going to complete the square on both numbers 1 and 2. I'll show you how to do the first one. We kind of work together on the first one. I'll let you guys do the second one on your own. So to complete the square on x squared plus bx, we take half of b, we take the result of that and square it. So let's see here. In number 1, what is the b?
3.
The b is 6. So half of b would be 3. And then when you square that,
9.
you get 9. And so in order to complete the square, what I would do is I would just go plus 9. Plus 9. So if you want to analyze why that's important or how that would work, let's factor the expression now in the green box. X squared plus 6x plus 9. How does that factor? Which numbers multiply to be 9 and add to be 6? 3 and 3, right? So that would give us x plus 3 squared. So again, what we see is the number in the factoring, the 3, is half of the b. The number in that factoring is half the b. So what we're trying to do is take something that is not factorable and make it factorable. Not only that, but make it a perfect square. What do you guys think about number 2? What do you think the b is? Well, the b is negative 9. What is half of the b? Can we use fractions? Not plus or minus, yeah. It's just, when I say half b, I'm literally saying take whatever it is and just cut it in half. Fraction-wise, what would it be?
9 over 2.
Negative 9 over 2. Okay, so then if we take that and square it, what is negative 9 over 2 squared? Stop using decimals. What is it?
81 over 4.
81 over 4, yep. 81 over 4. Okay, so what we would do is we would take that half b squared.
Can we reduce this or you don't want to?
I don't think I would want you to, but I don't think you can either.
Okay.
Yeah. Half b squared, if you tag that on the back, then it turns it into a perfect square. Now, the factoring on this would be significantly tougher, but if you remember that we just completed the square, and the number in the factoring is always the half of b, bless you, how do you think this factors?
X plus 4.5 squared.
Stop using decimals.
9.
I want you to use an improper, yeah. But it wouldn't be plus, though. It would be x minus 9 halves. Quantity squared. So it'd be a really tough factoring, for sure. But if you know your trick with the half b, then the factoring gets a little bit easier. Yes, sir?
Do you have any tissues?
I did. I think maybe they're gone. Maybe they got. You can use the restroom if you need to.
Okay.
It's totally okay. All right. So we're going to do a little bit of practicing here. We'll do a couple of these, and then we're going to practice these a lot at the board. Okay? So check this out. Number 3. Guys, I'm going to go slow here. Ask questions, including why, if you're wondering why, things like that I think would be really good. I would like to approach I'd like to approach this from the perspective of what if you were going to try to solve this and it did not give you the directions of complete the square? Let's think about how this could go.
You could do,
Use a what?
oh, never mind.
Sorry, no, I just didn't understand.
Oh, I was telling you the different ways that you could possibly go.
Oh, okay, yeah, yeah. Hey, this does not have to be solved by completing the square. I think this could be solved by other methods. I'm going to show you how to solve by completing the square, but I want to show you that it could work by other methods. So if you see a quadratic like this, and you think to yourself, how am I supposed to solve this? What is one of the ways that we have learned?
1/2 b.
Well, yeah, that's the newest thing, but what is one of the things from the past? I don't know what, oh, the X thing, yeah, the diamond thing, yeah, factoring. Let's see if that works on this one.
It doesn't.
Let's see. What numbers multiply to be -12, yet add to be +4? 6 and -2 actually work. It is factorable. So, this would factor as x plus 6, x minus 2 equals 0. X plus 6 equals 0, x minus 2 equals 0, therefore x equals -6, x equals 2. So in the past, if this had showed up in chapter 6, I would hope that you would have a good chance to get this right. What I wanted to do with this is point out to you that there's more than one way to solve these, and I also wanted to show you that based on what you've learned in the past, those are the answers, aren't they? Now what I'm going to do, I'm going to erase all this, and I'm going to show you how to actually solve this using completing the square, but let's remember that -6 and 2 are the answers. My point for doing this again, show you that there's more than one way to do these, and what I'm about to show you actually works. So remember the answers?
Yep.
All right, so they're gone. We're going to complete the square. I want to show you the steps on how to complete the square. Like I said, this is 100% new for most of you, and new-ish for the other folks, perhaps. So here we go. Step number 1, take the C to the other side. So I'm just going to say C goes to the other side. So that looks like this. X squared plus 4x equals 12. See ya. I like it. I like it. Okay, now create. Now you can do the first two steps in one if you want, but the next step is create space. So what I'm going to do is I'm going to write x squared plus 4x. I'm going to leave myself plenty of space, and then equals 12. So all I've done is just move the equals 12 off to the right. So obviously you could do that along with that first step. Wouldn't be too hard to do that. Now, what we're going to do is we are going to create a perfect square quadratic. And here's how we do it. Half of b squared, the thing we were just practicing earlier. So what is my b? So half of b is, half of 4 is 2, and then squared. Oh, that's pretty crazy. This is a pretty rare situation. 2 is a unique number, right? Because 2 times 2 is 4, 2 plus 2 is 4, and 2 squared is 4. It can be kind of deceiving to think that it's all the same process. It's not, of course. But in this case, we see that pattern kind of coming through. So here's what we do. With that half of b squared that we just figured out, we are going to add it, just like we were before. But now we have to acknowledge something pretty important. With an equation, isn't an equation basically a balancing act? You can't mess with one side unless you do the exact same messing with the other side, right? So I can't just add 4 to the left unless I also add 4 to the right. So this is kind of the big step. This is where I completed the square, and now we're going to work on finishing. But half of b squared added to both sides will complete the square and create that perfect square quadratic that we were working on. Now, here's how we finish. You guys all know, of course, 12 plus 4 is 16. But the big step here is let's factor. How does that left side factor? What numbers multiply to be 4 and add to be 4? Yeah, 2 and 2. So just like we were practicing before, this does create a perfect square trinomial or quadratic. Notice the number in the factoring relates to the b. How? It's half of b, right? It's half of b. All right, so to finish this, There's a reason why we warmed up with the couple of questions at the big board that we did. Doesn't this look just like what we warmed up with? So, what I'm going to do now is square root both sides to get rid of the squared. That gives me x plus 2 is equal to plus or minus 4. And now I will finally subtract the 2 over, giving me x equals negative 2 plus or minus 4. Now that's an okay answer, but you can definitely simplify it. We should be able to come up with the answers that we had at the start. So here would be my two paths I could take with the plus minus. Negative 2 plus 4 or negative 2 minus 4. This gives me 2. This gives me negative 6. And aren't those the same answers we got when we factored? Does that make sense? It's a pretty complicated process at this point in the game. Amelia, your question.
The number, the C that you moved over, will it always add out to be a perfect square?
On the right?
Yeah.
No.
Okay.
So that's a good question as far as the pattern here goes. If that number, like in this case the 16, if that is a perfect square, then in all likelihood your answers will be integers. But there are plenty of situations where these equations don't factor. And so those would be scenarios where that number would not be a perfect square.
Okay.
Yeah, good question. Anybody else with a question? Okay, so let's do one more. And then we'll go to the board to finish things up. And finally, everybody will get their chance at the board. So take a look at number 4. Yeah, this will be a good one. This is one in which factoring does not work. And so one of the methods that works here is completing the square. So feel free to reference the steps that we did before in order to get this one solved. Try it. I think you can do it. If you can't, it's okay. I'll help you and we'll practice. All right. So this gives you really direct instructions. It says use complete the square to solve. So again, let's just remind ourselves of how these steps go. I am making a video of this, and so if you're working on your web assignment later on and you wanted to watch this to review, if you kind of forgot the steps, you certainly can use this along those lines. So step 1 is C goes to the other side. So I'm going to add 5 to both sides, x squared minus 8x, and I'll just leave space right now. Right? So take C to the other side, leaving a blank space where the C used to be. The next step is, you can do this off to the side, is to find half of b. And what is half of b?
4, negative.
The sign needs to go with it. So it's negative 4. And then we square that. What is negative 4 squared? 16. So we'll take that half of b squared and we add it to both sides. So plus 16 and plus 16. Of course, 5 plus 16 is 21. But now we need to factor the left side. It should factor as a perfect square. And what number should always be part of the factoring? Half of b. Right. So in this case, the half of b was negative 4. If you do factor it, you'll see that it's the same as what you would have expected with the half of b, x minus 4 squared. At this point, we want to square root in order to get rid of the squared. We end up with x minus 4 equals plus or minus root 21. So I encourage you to put the plus or minus in as soon as you square root both sides. Our final step here would be to add 4 to both sides. So x is equal to 4 plus or minus the square root of 21. There's a perfectly acceptable form for an answer there. As somebody was mentioning WebAssign, they might want you to actually split it. 4 plus root 21, 4 minus root 21. That's fine, of course, as well. You could convert this over to a decimal using a calculator, depending on what the question was asking. I saw a lot of correct answers. How are you feeling?
Good.
Good. Okay, awesome. Let's practice. Let's go to the board. What I want you guys to do this time at the board is I want to go, we've done this a couple